Right, good evening. This isn't the video I was going to make today, but circumstances have fought against me this week. First thing that happened was I had to spend 4 hours in a hospital because I had an accident at work, which didn't do me any favours, but I'm actually okay, so just in a lot of pain. Nothing really too serious. So not been lifting, cutting, drilling, sawing any sort of materials. What I've got on the bench here in front of me is just sort of a culmination of the week of what's been going on. One thing that did happen last week, just before I went back to work, is one of our flat panel tellies in the bedroom blew up, which really wasn't very good. It didn't actually blow up, it just refused to switch on anymore. It's not the first time it's happened, and I ended up getting a pair of replacement boards from eBay. These are the ones that have come out. So what's going to happen with these is I'm going to take the capacitors off, heat sinks, just generally strip that board down completely, because it has, as a power supply board, it has quite a lot of decent rated parts on it. I know most people say, ooh, TV power supply boards, they're always blowing up. Well, yes they are, but that's probably because they're trying to save money and do things on the cheap, whereas some of these components will work quite happily in valve amplifiers. These heat sinks are perfectly adequate for, say, a 1 amp regulator, something like that. You've got your X-rated capacitors, a small bridge rectifier there, I think, yes, a bridge rectifier, your MOVs, your high voltage caps, even if I really want to, I could strip the copper wire out the transformers, but I probably won't get that far. These inductors may be useful as signal chokes. So that's what's happening with that board. This board is the main control board of that. Not really a lot on there worth salvaging. You know, it's one of those, I might take the crystal off, I might, well, I have the USB socket. Yeah, so anyway, well that's the dead telly, so let's stick them over there. The heatsink did arrive for the power supply unit, which I'm very impressed with. Now, as you see, it is quite small to dissipate the amount of heat that is generated by the 4-pass transistors, but I've got to say, kudos to the seller. It came from China and it came in less than a week, which is pretty good, I would say. So yeah, great one for the seller there. Now, along with that, I did dig out in my spares box and I found this stack of fans, and I thought I might get away with it, but the heatsink was just that little bit too small for getting 2 fans dead on side by side. So what I'm going to do, if I just move those other 2 out of the way, they're all the same. These are actually 24 volt or 12 to 26.5 volt Pabst fans. I can't remember where I got them, but yeah, they're very good, they're very efficient. A little bit noisy, but then I didn't buy them for silence, I bought them for airflow. As you can see, you know, apart from all my greasy fingerprints all over it, they're not quite going to fit straight on the heatsink. So what I was going to do, just to make sure that they do fit, I was actually going to maybe just mount the centre holes through the heatsink with some threaded rod, and then just put in a support bracket at the top. Now the reason for doing that, now these are upside down at the moment, the fans actually should be that way up, and the way you can tell is if you look around the body of the fan, you can see that there is actually a direction arrow alongside the positive and negative terminals. So they go that way up, and as I say, I would mount them maybe about 5 or 6 mil above the heatsink, so that all the airflow goes across the top of the heatsink really. I didn't know whether to have it pushing or pulling, but I thought, well, forcing air on is better than pulling air off. If somebody's got a better idea, then tell me. So what I can do, if I move those out the way for now, make sure it doesn't fall on the floor, I don't want to damage it. Let's get the power supply leads. Make sure I've got the right ones, positive and negative, and then turn on the current. Now these things only need, what do they rate it at? 6 watts, 245 milliamps at 25 volts. Now at the moment that's at 15 volts, and I don't know how I can show you maybe a bit of, as you see, there's a fair amount of airflow there. If I turn the voltage up to the full, right, that's the 26 volts it's rated at, and that's a single fan. As you see, quite noisy. Let's turn that right down. That's actually back down at 14 volts. So you're still getting a fair old airflow. So that's what I was going to use for the cooling of the project. So let's move that out the way. Turn that back off so you can hear me properly. So yeah, as you see, it's very free running bearings, but then Pabst always did make very good fans. So that's the fan modules. What else did I do? Right, okay, this is a little plug for Bright components. Let me turn them round. If you search on eBay for electronics components, I've got to say these guys are brilliant. Let me just zoom in for you. Let's see if I can, and then hit the focus. Yep, there we go. Right, as you see, Bright components, always been next day delivery, and they combine shipping. So yeah, can't argue with that really. So let's just bring you back out, not that way, let's come back out that way, see if I can focus you in again. Yeah, there we go. So Bright components, yeah, thanks very much guys. Next day as always with them. So that's more components there for the 1957 amplifier. They're just some of the high voltage polyester caps that I didn't have in stock. So again, they can go in the other project box. What else was I playing with? Oh yes, that's right. Part of the project was to put this sort of voltmeter on there with this shunt. Now, I was doing some tests, and somewhere somebody's got their calculations wrong. This meter is certainly not set up for this shunt. Now it is engraved on the side that it's a 50 amp 75 millivolt full scale shunt, but putting an amp through it, the meter reads 6 amps. So somewhere on the programming, probably one of these links up in this small corner here. Again, I'm going to try and bring it in and see if we can get a focus on that. Yeah, there we go. Maybe, no, not quite. Come on, in you go. Let's go with a manual focus, see if I can get it in that way. There we go. Right, on this board there are some very small links just up by this chip here, which I would imagine are for the range of this meter. But can I find this diagram online anywhere? No, I can't. So let's come back down to the bench. So I'm looking for that still. But on the other hand, I have seen, who was it? I believe it was Julian Illett, doing an Arduino voltage current meter, and that set me thinking, that might be a good idea. So I'm currently looking at using one of the Hall effect sensor chips, again rated quite highly, one of the 50 amp jobs, just to give it some overhead, and connecting the whole front panel for volts and amps to an Arduino, and also possibly to give me the heatsink temperature as well. I might put the thermal sensor in on the Arduino as well. There should be enough inputs and outputs to allow me to run an LCD display along with the other inputs. So yep, that's that. So they can go in the project box over there. So what have we got left to talk about? Just to prove that I don't buy everything off eBay, thank you Farnell, TO220 and TO3, and there's the other bag, TO3 mica mounting kits, just as cheap from Farnell as they are from eBay, and as long as you spend enough with Farnell, it's next day free shipping. So yeah, I tend to buy certain stuff from Farnell. So now we've got just a couple of bits left. Sorry for the waffling. I got these. These were another flash deal. I can't remember whether it was Ali or Banggood, or well, whichever one of the two it was, but it was a flash deal, and I thought, right, okay, let's play silly beggars. And they're daytime running LEDs is what they're advertised as. Now whether I'm going to use them as daytime running LEDs, there we go. As you see, you'll see if I keep the current on there. These they come with very small, very light wires, so there we go. You can see that that's green, but yeah, I have tested all of these, and let me just up the current a bit so that it can run properly. There we go. Each one of these draws roughly 80 milliamps, and it's two LEDs. As you see, they are rather bright. If I just hold my hand over there like that, you can probably see just how much they do light up. So yeah, I bought 10 of them for fun. I do actually already have some of these and some white ones as well. If I ever get round to getting a nice day and not having a back full of pain, I will possibly fit them to the front of the car just to be different, because I can, or I might use them on a control panel somewhere. It'll be bright, which leaves us with, just turn the power supply off, this little bag. Now, when I was looking at building a high current power supply, I didn't know whether to use the existing analog type kits and then add some pass transistors, basically modify an existing design, or build completely from scratch. So I did actually buy basically this kit here. Well, I actually got a few of them because they were cheap to buy, as more than one. And I'm still debating now whether to build this and use this to drive the pass transistors, or whether to still go for a scratch build in the big power supply. It's 6 of one, half a dozen the other, really. But either way, that is a 0 to 30 power supply kit, all ready to assemble. Basically, you just throw it together, and the one thing that they don't supply is a heatsink for the main output transistor. Now, they say this is good for 2 amps. You'll be pushing it, I'll be honest. I think unless you've got some monster heatsink on there, amp and a half is about all you'll get out of it. So yeah, there we go. That's the update for now, and hopefully next week we'll have some progress. I did actually get the sheet aluminium in for the front panel of the power supply. What else did come in? Oh yeah, I did have a catastrophic hard drive failure, and I managed to lose all my family pictures, which just goes to show, back everything up. And yeah, just back everything up rather than leave it to chance. So I've been replacing hard drives in the main PC as well. And what else has happened? That's really about it. Not a lot else. And yeah, so thanks very much for watching, and hopefully it hasn't been that boring for you. See, the time's cracking on. We have changed over. We lost an hour on Sunday, didn't we? So yeah, still trying to get the sleep patterns back to normal, but the medication isn't helping. What are we, 10 to 2 in the morning? Oh, we're getting about right. Thanks very much. Bye bye.